Something strange has been happening around the Pacific Ocean lately. Volcanoes erupting, earthquakes clustering, seismic swarms appearing beneath regions that normally stay quiet for years. From Japan to Indonesia, from Alaska to Chile, scientists have been watching activity increase across multiple parts of the Pacific Ring of Fire almost simultaneously. And honestly, the pattern has started making people uneasy. Not because geologists think the entire planet is about to explode. That's not how tectonics works. But because the Ring of Fire is Earth's largest and most violent geological system. When multiple sections become active around the same period, scientists pay attention. The Pacific Ring of Fire surrounds the ocean like a giant horseshoe-shaped fracture zone, stretching more than 25,000 miles around the planet. And along that massive boundary, tectonic plates constantly collide beneath the ocean floor, releasing pressure. Most of Earth's strongest earthquakes and most dangerous volcanoes exist along this single system. That alone is terrifying. But lately, the activity feels different. Japan has experienced unusual earthquake sequences. Indonesia continues dealing with frequent volcanic unrest. Alaska's volcano monitoring systems remain extremely active. Chile and Mexico repeatedly face strong seismic events. Entire regions around the Pacific are shaking, deforming, or erupting more often than many people remember seeing in recent years. Now, scientifically, this does not automatically mean one giant connected disaster is coming. Researchers are careful about saying that. Tectonic systems are incredibly complicated. Some earthquakes happen randomly. Some volcanic systems awaken independently. Correlation does not always mean direct connection. But here's the uncomfortable part. The Pacific Ring of Fire is physically interconnected through enormous tectonic plate boundaries beneath the ocean. And stress in one region can sometimes influence nearby systems over time. That's why scientists monitor patterns so carefully, because Earth's crust doesn't behave like isolated countries on a map. Deep underground, the plates interact constantly across enormous distances. Magma systems respond to changing stress fields. The entire Pacific Basin is basically sitting on a gigantic moving machine humans cannot stop. And sometimes that machine becomes more active. That's what has researchers watching so closely right now, especially because history shows what the Ring of Fire is capable of when major systems rupture. The 2011 Japan earthquake and tsunami, the 2004 Indian Ocean disaster, the eruption of Mount Pinatubo, Krakatoa, Chile's megaquakes, Alaska's massive seismic events. Some of the most catastrophic natural disasters in recorded human history came directly from the Ring of Fire. And tonight, millions of people living around the Pacific Ocean are going about completely normal life. Airplanes crossing the Pacific, cargo ships moving between continents, cities glowing beside coastlines. Meanwhile, beneath the ocean floor surrounding nearly the entire Pacific Basin, tectonic plates are still grinding against each other in the dark. The Ring of Fire is not one fault line. That's important to understand. It's an enormous network of tectonic boundaries wrapping around almost the entire Pacific Ocean. A gigantic geological machine operating continuously beneath some of the most populated regions on Earth. And honestly, the scale of it feels almost unreal. The system stretches from the west coasts of North and South America, up through Alaska, across Russia and Japan, down through the Philippines, Indonesia, Papua New Guinea, Tonga, and New Zealand. Nearly 75% of Earth's active volcanoes exist along this single zone. Around 90% of the planet's earthquakes happen here too. That's why scientists call it the Ring of Fire, because the edges of the Pacific are basically lined with volcanic arcs and seismic fault systems constantly releasing planetary pressure. And underneath all of it, tectonic plates never stop moving. The Pacific Plate itself is enormous, one of the largest pieces of Earth's crust on the planet. Around its edges, smaller plates collide, dive, scrape, and grind against neighboring continents and oceanic systems. Scientists call many of these boundaries subduction zones. That word matters, because subduction zones create the most violent geological disasters on Earth. A dense oceanic plate gets forced beneath another plate deep into the mantle. The plates lock together due to friction. Pressure builds for decades, sometimes centuries. Then eventually the fault ruptures catastrophically. That rupture becomes a megathrust earthquake. And because these systems sit beneath oceans, they can also generate tsunamis powerful enough to cross entire seas. That's exactly what happened in Japan in 2011. The The Pacific plate suddenly slipped beneath northeastern Japan during a massive rupture. The seafloor moved violently upward, and within minutes, entire walls of ocean water raced toward the coast. The disaster killed nearly 20,000 people and triggered the Fukushima nuclear catastrophe. But Japan is only one section of the Ring of Fire. Indonesia sits on another intensely active portion, where multiple tectonic plates collide simultaneously beneath thousands of islands. That region produces constant earthquakes and volcanic eruptions because the crust there is under almost non-stop stress. Then there's Chile, one of the most earthquake-prone countries on Earth. In 1960, Chile experienced the strongest earthquake ever instrumentally recorded, a magnitude 9.5 megathrust event generated by the Nazca Plate diving beneath South America. The tsunami crossed the Pacific Ocean itself. That's how powerful Ring of Fire systems can become. Even Alaska contains some of the most dangerous subduction zones on the planet. The 1964 Alaska earthquake reached magnitude 9.2. Entire coastlines permanently changed elevation. Some regions sank several feet instantly, while others rose upward. That's the kind of force tectonic systems around the Pacific are capable of releasing. And honestly, one of the strangest things about the Ring of Fire is that humans rarely think about it as one connected structure. People think about Japan separately from Chile, Indonesia separately from Alaska. But geologically, they are all pieces of the same enormous tectonic network surrounding the Pacific Basin. A planetary pressure system continuously redistributing stress through Earth's crust. Now, scientifically, this does not mean one earthquake directly causes all others around the Pacific. Researchers are very careful about oversimplifying that idea. The Earth is too complicated for simple domino effect explanations most of the time. But tectonic stress absolutely can influence nearby systems. Large earthquakes can alter pressure distributions along connected faults. Volcanic systems can respond to changing crustal stress. Subduction zones interact regionally over time. That's why scientists watch the broader pattern of activity carefully, especially during periods when multiple regions begin showing increased unrest simultaneously. Because the Ring of Fire never truly rests. Even during quiet years, the plates keep moving beneath the Pacific. The pressure keeps building. Magma keeps rising beneath volcanic systems. And lately, more sections of that gigantic geological machine appear to be waking up at the same time. Scientists are careful people. That's important. Geologists usually avoid dramatic claims unless the evidence becomes overwhelming. So, when researchers begin openly discussing increased activity around the Ring of Fire, people tend to listen closely. And lately, there have been a lot of reasons to watch the Pacific carefully. Japan continues experiencing unusual earthquake clusters near major tectonic boundaries. Indonesia regularly monitors multiple volcanic systems, showing elevated unrest at the same time. Alaska's seismic and volcanic networks remain highly active year after year. Tonga experienced one of the most violent volcanic eruptions observed from space in modern history. Chile continues recording powerful earthquakes along its subduction zones. Mexico repeatedly faces seismic swarms near heavily populated areas. None of these events automatically mean a global tectonic crisis is beginning. Scientists emphasize that constantly. The Earth naturally experiences earthquakes and eruptions every year. The Ring of Fire is supposed to be active. But what researchers watch carefully is the pattern, and especially whether stress may be redistributing through connected plate systems. Because tectonic plates don't behave like isolated objects. When large earthquakes happen, they can slightly alter pressure conditions across nearby faults. Sometimes those changes remain tiny. Other times they may influence volcanic systems or seismic activity regionally. That doesn't mean one eruption magically causes another across the Pacific. Real geology is far more complicated than internet conspiracy theories. But scientists absolutely study how stress transfers through tectonic systems over time. One of the clearest examples happened after Japan's 2011 earthquake. Researchers discovered the massive rupture changed stress conditions across portions of northeastern Japan and surrounding regions. Volcanic systems responded differently afterward. Some fault zones experienced altered seismic behavior. The crust itself physically adjusted after the megathrust event. That's why major earthquakes attract global scientific attention, because the energy involved is enormous, And recently, the Pacific has experienced repeated periods where multiple major systems showed unusual behavior within relatively short time frames. Again, scientists avoid panic, but they also don't ignore patterns, especially when volcanic unrest begins increasing simultaneously across several highly active regions. Take Indonesia, for example. The country sits on one of the most geologically violent sections of the Ring of Fire anywhere on Earth. More than 130 active volcanoes exist there. Entire populations live beside systems capable of explosive eruptions, earthquakes, tsunamis, and pyroclastic flows. Some volcanoes remain active almost constantly. Others can stay quiet for decades before suddenly erupting with devastating force. Then there's Alaska. Many people forget how volcanically active Alaska actually is, because much of the region feels remote. But the Aleutian Arc contains numerous active volcanoes connected to intense subduction beneath the North Pacific. Ash clouds from Alaskan eruptions can threaten international aviation routes across the Pacific almost immediately. And scientists there monitor seismic swarms constantly because magma movement underground often begins with earthquake activity. Meanwhile, farther south, Chile and Peru continue sitting directly atop one of the fastest-moving subduction systems on Earth. The Nazca Plate keeps diving beneath South America relentlessly. Pressure accumulates continuously. That's why some of the strongest earthquakes in recorded history occurred there. And honestly, one of the most psychologically unsettling things about the Ring of Fire is how normal life continues during all this activity. People commute to work in Tokyo. Tourists visit Bali. Cargo ships cross the Pacific. Families live beneath volcanoes that may erupt again someday. Entire megacities operate beside faults capable of catastrophic rupture. Human civilization around the Pacific has essentially learned to coexist with constant geological instability. But scientists know something important. The Ring of Fire never truly becomes stable. The system breathes in cycles. Then quiet periods return temporarily before the cycle continues again. And lately, enough systems around the Pacific have shown elevated activity that researchers across multiple countries are watching the broader tectonic picture very closely, not because they know exactly what happens next, but because beneath the Pacific Ocean tonight, the largest geological system on Earth is still moving. The real danger of the Ring of Fire is not one volcano or one earthquake. It's the possibility of multiple major systems becoming unstable within the same broader period of time. Because modern civilization around the Pacific is deeply interconnected, a massive disaster in one region can ripple across the planet almost immediately. Now imagine several major geological crises happening around the Pacific within months or years of each other, not because the Earth is ending, but because the Ring of Fire naturally operates in cycles of pressure release across huge tectonic systems. That scenario keeps emergency planners awake at night. Imagine this for a second. A major megathrust earthquake strikes near Japan. Tsunami warnings spread across the Pacific within minutes. Ports shut down. Shipping routes freeze temporarily. Air traffic reroutes. Factories stop production. Global supply chains immediately feel the shock. Then, weeks later, a major volcanic eruption disrupts aviation routes in Alaska or Indonesia. Ash clouds spread across the atmosphere. Flights are canceled across huge regions. Trade slows again. Meanwhile, another strong earthquake hits along the west coast of South America. Infrastructure systems already under pressure become even more unstable. Emergency resources stretch thinner across multiple countries simultaneously. That's the uncomfortable reality scientists and disaster planners increasingly think about. Because the Pacific Ocean is basically the central artery of global trade. Some of the busiest shipping lanes on Earth cross the Pacific Basin every single day. Massive ports in Japan, China, the United States, Chile, Singapore, and other Pacific nations move enormous portions of the world economy continuously. And many of those ports sit directly beside active fault systems or vulnerable coastlines. A major Ring of Fire disaster could disrupt global systems far beyond the immediate impact zone. That's exactly what happened after Japan's 2011 earthquake. The disaster didn't stay inside Japan. Supply chains worldwide experienced shortages because factories, ports, and transportation systems were suddenly interrupted. Now multiply that kind of disruption across several Pacific regions. The consequences become difficult to fully model. And honestly, volcanoes may be even more underestimated than earthquakes sometimes, because volcanic eruptions don't just threaten nearby towns. Large eruptions can affect entire atmospheres. Ash clouds can ground airplanes across continents. Sulfur aerosols can alter climate temporarily. Agricultural systems can suffer if sunlight decreases regionally. Water systems become contaminated. Infrastructure collapses under ash accumulation. Some eruptions become so explosive they generate lightning storms inside giant ash plumes visible from space. That happened during the Hunga Tonga eruption in 2022. The blast was so violent, satellites captured atmospheric shock waves, rippling outward across the planet. That's how much energy volcanic systems inside the Ring of Fire can release. And then there are tsunamis. One major underwater rupture can send waves across entire oceans. The Pacific Basin's geography actually allows tsunami